Okay, so we have the derivative, slight modification. The derivative of cosine up here would be a negative sign. So this is actually minus 6 sine cubed of x, which means that if I want to find x2, then I'm going to take, let's see, x2 would be equal to x1, which is 0.5, minus f of x1, which would be 6 cosine 0.5 sine squared 0.5 minus 1. Okay. Divided by, oops, just this part divided by the derivative evaluated at 0.5. So it'd be 12 sine of 0.5 cosine squared 0.5, right? Minus 6 sine cubed of 0.5. And I would have to use that to find x2, and then use that x2 value to find x3, etc. I want to find the 10th approximation. So I am actually going to use Excel, which is very helpful for iterative methods, for repetitive calculations like this. Okay. So let's go here. Okay, so this is Excel. And I'm going to say these are my xn values. And the values I'm going to calculate on the right-hand side. My first xn value is 0.5. Okay. And I'm going to say in here, I'm going to type my function. I know it looks confusing here, but A1 is the value that I have here. Excuse me. Let me actually delete that because I have it typed as A1. There we go. So A1 in this function is the value that I have in here. And then I'm evaluating my function over my derivative at that value. Okay. I need an equal sign in there to make it calculate for me. Okay. And it looks like my x2 value is that. So I'm going to put that x2 value there. All right. If I drag this down, then Excel will calculate my x3 value. It'll take all these same calculations, this same function, except it'll calculate it for this A2 value here. And I can click on it and note that it has replaced all my A1s with A2s. I'm going to do that same thing. Put the A2 value here, drag the function down, and I'll go ahead and make notes as to what these are. Let's see. There we go. Okay. So this would be x1. This would be x2. This is x3, x4, x5, x6, x7, x8, x9, and x10. I want to find x10. Okay. I'm just going to go ahead and drag this all the way down to x10. It'll keep repeating the values. This is equal to that. This is equal to that. Okay. It'll keep repeating those values. Make sure that this is actually equal to that. Yep, it is. So it appears that this value here is my x10 value. If you remember from the graph that you created, Desmos gave the intercept, one of the intercepts at about 0.4 0.4444. I think it approximated to 0.4441. This is an even closer approximation. You can see it's rounded to 0.4441. But it carries it out to more decimal places. I could have Excel find closer approximations, but something you might notice here is after x3, or after x4, excuse me, these values repeat. So this is probably a very, very, very close approximation to the actual root near that starting x value of 0.5. So we let Newton's method approximate the value of the intercept for us. And we didn't actually have to use a computer or a graphing program to do that. Okay? So that is Newton's method for you. There will be a few problems in your homework from this, not many, because we didn't go over it for very long. But I thought it was worth showing it to you since we did get stuck without a way to solve that problem on your online homework. All right. And that is all for today. I'll talk to you guys later.